In modern manufacturing, the production line operates under a severe physical constraint. To build at scale, you need high-velocity throughput. But to build safely, you have to spend time physically verifying microscopic tolerances. If you are milling an aerospace turbine blade or machining a titanium medical implant, being off by a few microns renders the part completely useless. Historically, ensuring that exactness meant pulling parts off the line and sending them to a separate quality assurance lab. Physical measurement is methodical and slow. It introduces a post-production choke point that effectively halts the assembly line. Resolving this bottleneck requires breaking quality inspection out of its isolated silo. It must be structurally integrated back into the active manufacturing ecosystem. The PolyWorks metrology suite functions as a comprehensive integration platform built exactly for this purpose. This diagram illustrates how PolyWorks resolves the conflict between production speed and inspection precision. By linking isolated data from design, manufacturing, and quality into a continuous, real-time loop, the platform constructs a digital thread. Success in Industry 4.0 relies on quality inspection functioning as the real-time nervous system for the factory floor. The foundation of this system begins at the physical level, acquiring raw dimensional measurement data from the factory floor. The industry standard for capturing highly precise coordinate data is a coordinate measuring machine, or CMM. It uses a physical probe to map exact anchor points through direct contact. Conversely, 3D laser scanners operate without physical contact. They rapidly sweep over broad surface areas, mapping the component's exterior. This creates an immediate data engineering problem. Contact probes output discrete, individual point coordinates. Lasers produce heavy, dense point clouds. In this model of an automotive chassis, we can see how PolyWorks acts as the foundational translation layer. It is built to simultaneously ingest and align both streams of data. We have precise CMM coordinates mapped to key structural joints, while a laser line sweeps the broader, flat body panels into dense point cloud meshes. This multimodal ingestion merges these disparate physical inputs into a single analytical environment. This high-density, unified 3D model functions as the definitive digital twin of the physical part currently sitting on the assembly line. The scale of this raw data is immense. A single scan contains millions of individual geometric data points. Capturing a massive dataset is only the first step. Without intelligent processing, high-volume digital twins simply shift the physical bottleneck into a digital one, leaving engineers with more data than they can quickly analyze. Traditionally, analyzing that dense point cloud required highly skilled engineers to spend hours writing manual software programming, carefully clicking to identify individual geometric features within the raw data. To clear this analytical sink, PolyWorks utilizes AI to introduce algorithmic metrology. This animation shows a raw point cloud model. Watch how the PolyWorks AI algorithms systematically scan the data. Instead of manual selection, targeting nodes automatically recognize specific structural elements like bores, fillets, and chamfers as they sweep past. The system instantly extracts these complex geometries mathematically. Without a single human click, it isolates the features and snaps precise measurement vectors, such as radius, depth, and angle, directly onto them. These extracted measurements are immediately compared against the original CAD tolerances to check for any deviations. Automating feature programming eliminates manual setup hours, it minimizes human errors, and routine reports generate automatically. This shift frees up skilled metrology technicians to focus on strategic problem-solving and process improvement, rather than repetitive software programming. The result is a rapid, continuous flow of analysis that easily outpaces the start-stop nature of localized physical inspection. AI shifts metrology from a manual data processing chore into an automated analytical engine, restoring speed to the precision equation. Once the data is analyzed, we have to look past the individual factory floor and examine the broader multi-site global manufacturing footprint. A meticulously analyzed dataset is ultimately useless if it remains trapped on an isolated local hard drive in the QA lab. To solve this, the PolyWorks cloud architecture serves as the vital synchronization layer for the modern enterprise. This global topology map illustrates the network architecture. As soon as a local machine finalizes an AI-processed inspection report, That packet is pushed to a centralized, secure cloud server, which immediately routes continuous data lines to identical factory setups across the globe. This establishes strict version control. As the incoming metrics synchronize, every global team is guaranteed to be viewing the exact same updated dataset. Total centralization allows engineering nodes, whether design in Europe, manufacturing in Asia, or quality assurance in North America, to collaborate in real time. Production managers can now access real-time digital dashboards directly from this cloud, allowing them to make immediate, data-driven decisions. Sensitive intellectual property, particularly in aerospace and automotive design, remains protected by robust security protocols integrated directly into the cloud layer. Because the feedback loop is immediate, plant operators can make instant tooling adjustments on the assembly line, correcting minor deviations before they compound into massive downstream errors. The cloud layer bridges the final gap. It transforms isolated factory metrics into a true digital thread, ensuring that a micron-level deviation detected in one facility instantly informs and protects the entire global enterprise. The complete structural architecture operates in 3 distinct phases. Multimodal physical ingestion feeds into AI feature recognition, which is then pushed out via a globally synchronized cloud. In this animated diagram, you can see how this connects design, manufacturing, and quality assurance into a single unified continuum. The loop is entirely closed. Watch as the data speed increases and the nodes pulse synchronously. This closed-loop architecture converts inspection into a proactive, real-time feedback mechanism, replacing the traditional post-production audit. Looking to the future, this exact data infrastructure provides the required foundation for implementing predictive quality modeling. By amassing historical, highly traceable inspection data, manufacturers are training AI systems to accurately predict and prevent quality issues before a part is even milled. The fully autonomous smart factories of tomorrow rely entirely on this level of integrated, automated metrology to operate without human intervention. Implementing the PolyWorks metrology suite provides the structural framework needed to maintain a competitive edge as manufacturing becomes increasingly automated.